In order to answer A, you need to consider the combinations formula, which is n factorial over n minus r factorial, r factorial. You can then compare that to what is given, which is 11 factorial over a factorial, 9 factorial. Well, a has taken the place of r. Therefore, we know that 9 minus r is equal to 9. We know that n is 11. Therefore, 11 minus r equals 9. Therefore, r, or in this case, a, is equal to 2. We can now use that in part B to find the coefficient of x to the power of 9. To find an individual term, we know we have n choose r, x to the power of n minus r, y to the power of r. Therefore, we've got 11 choose 2, x to the power of 11 minus 2, y to the power of 2. We can now substitute in. Therefore, we want to find 11 choose 2, x to the power of 9, 3 squared. 11 choose 2 is 55, times 3 squared, which is 9, x to the power of 9, which when you work it out is equal to 495 x to the power of 9, so the coefficient is 495. In this question, we have a binomial raised to the power of 10. That means there is always one more term than the power, so a is equal to 11. There are 11 terms in the binomial expansion. In part B, we need to find r, because we have x in both terms. So we have got 10 choose r, x to the n minus r squared, plus 2x to the minus 1 to the power of r. And we want that to equal some coefficient of x to the power of 8. Isolate the terms that give us a power of x and multiply out. So we get x to the power of 2 times 10 minus 2r times x to the power of minus r, and that's got to equal x to the power of 8. We can now compare coefficients. So we get 20 minus 2r minus r is equal to 8. Therefore, 3r is equal to 12. Therefore, r is equal to 4. We can now use r is equal to 4 to find out the coefficient. So we get 10 choose 4 times 2 to the power of 4. 10 choose 4 is equal to 210. 2 to the power of 4 is 16. When we multiply those together, we get 3,360. So the coefficient of x to the power of 8 is 3,360.